Let's look at describing trends in scatter plots. Now we've already looked at scatter plots, and we've looked at the linear associations and nonlinear associations, and we're going to take a look here now at how we can actually describe the trends that show in scatter plots. So with a lot of these questions, you could probably just go straight to the data, and you could probably look at the data and figure out what the question is about. Well, here I've got data here, and it shows me, well, I've got the average number of buses per hour and the number of complaints. Well, this must be something to do with buses arriving at a bus stop perhaps, and maybe they're arriving late or something like that, and because of that there are complaints. If there's only 2 buses arriving in an hour, you get more complaints, for example. If you've got 7 buses arriving in an hour, you got less complaints, is my guess on this. So just to give you an idea, if a scatter plot is done correctly, we looked at making good scatter plots before, and if a scatter plot is built correctly, you can probably theorize what the data is about just by looking at the scatter plot. Well, let's read the blurb. A bus company wanted to know if the number of complaints they received was a function of the number of buses it ran. The company carried out a study comparing the average number of buses per hour for different days and the number of complaints it received on those days. The results are shown in the graph below. So similar to what we were looking at, the bus company, average number of buses that it runs per hour, and the number of complaints it receives. So we can see here, the less buses it runs, more complaints. The more buses it runs, the less complaints, is what we're looking at right here. And just by looking at the data here, we can probably figure out what the question is. It's asking us which statement is the best description of the association between these variables. The first one, there tended to be more complaints on days with more buses. Well, no, that's not true. The more buses you have, the less complaints you have. It's these data points down here. The more buses you have, the less complaints you have. There tended to be fewer complaints on the days with more buses. Well, that's the one that's true. We can see clearly there is a linear association right here, a reasonably linear association right here that points to there being fewer complaints on days where there are more buses per hour. Let's take a look at a few more. So we can read here, why not? We can look down here, figure it out if we like. The graph below shows the relationship between life expectancy and income in a random sample of countries. So if you didn't look at the countries part, you might think that this is based on people. The higher their income, the longer they live, perhaps. Is that what we're looking at here? We can kind of see, I mean, that this doesn't quite fit the data perfectly, but we can see that there is a reasonable correlation, and it makes a lot of sense now when we look at it in terms of countries as opposed to just as opposed to just a sample of people. Well, the countries that have low average income, they actually have quite a large range. So that makes a lot of sense because, well, there's other factors to life expectancy than income. Right? But the further we go up, the higher we go up, looking at the average income, and the higher the average income climbs, we can see that maybe it's due to other factors like the higher the average income, the better access to health care, and so on and so forth. That we can see that the higher the average income in a country, the longer people are living in that country, and that's probably reasonably accurate. So what we can see here, we've got clear data that we can describe just from looking at the scatter plot, and then when we look at what we're being asked to choose, it all starts to come together. So countries with higher income tended to have longer life expectancies, and we found that to be true. The other options, well, there is a reasonably clear relationship, so we can choose that. Higher income tends to have shorter life expectancy. Well, that's not true at all. The short life expectancies are all with lower income countries. Let's take a look at one more, and once again, just skipping down to the graph because we can see if we can actually figure it out just by looking at the graph. We will read the question, of course. You should read the question for every question, but it is kind of fun just to look at the graph and figure it out. We've got speed and fuel used, right? So we're looking at the speed of something traveling It looks like the lower the speed, it's using a greater amount of fuel. That's liters per 100 kilometers, so it's using a greater amount of fuel. The faster it gets, that amount of fuel seems to be decreasing. It's using less and less fuel as it gets to a point, as it gets to about 60 miles an hour, or kilometers per hour, and then the faster going from there. That's probably that point in the engine where your revs need to climb higher in order to go faster, and we can see the faster you go from there, the faster you're burning fuel. So there's always, with any vehicle you're driving, there is always that equilibrium point. It's usually lower than 60. Well, 60 kilometers per hour is about right. It's usually lower than 60 miles per hour is what I'm saying. But there is this equilibrium point where you've got the highest fuel efficiency, which is the least amount of fuel used. So this looks like a single vehicle, perhaps. Lynn wants to predict how much fuel her car will use based on its speed. It's exactly what we're hypothesizing. She drove her car 100 kilometers at each of the speeds below, and she measured how much fuel was used in each case. Her data is summarized in the graph below. Well, this data is only good data if she drove the same 100 kilometer every single time, as opposed to driving, say, up a mountain or down a mountain. But in this case, we're going to assume that is the case. We can see here that we've got some different things. We're not necessarily being asked about higher speeds, lower speeds, and so on. This is clearly nonlinear data. Driving at higher speeds always results in less fuel being used. Well, not necessarily. The higher you go here, you're using more fuel than down here. On the other hand, the amount of fuel used was lowest at speeds around 60 kilometers per hour, and we see that to be true. So these are questions that you can figure out just by looking at the graph. I highly recommend you read the question along with it just to give you some context. But try to answer yourself some questions that you might have just by looking at the data before you look at the options, because 9 times out of 10, if you're analyzing this data correctly on the scatter plot, you will already come up with the answer before you ever look at your possible answers. Okay, so try that out for yourself. Let me know how you get on.